Hello students, welcome to my lecture on the subject Theory of Machines. I am Dr. Ashish Vikhar and I am here in front of you to explain the very first chapter of Theory of Machines. Before proceeding, I would like to appeal to you all to subscribe my channel Dr. Ashish Vikhar, or you can visit my website drvikhar.com. Today we will start unit number 1, and in front of you on your screen you will see lot of machines, and what is the theory behind all these machines, that we will learn today. After studying this unit number 1, there are certain outcomes that you will gain, and let us see one by one which are these outcomes. After learning unit number 1, you will be able to identify various links in the given figure of the mechanism, and you will be able to give the justification also. Theory of machine is a subject which is related to machines and mechanism. So that's why this unit outcome 1 is given to you. You will be able to identify which are the different links in a given figure of the mechanism. Second unit outcome is you will be able to describe with sketches the constructional details of the given type of mechanism. So if a sketch of mechanism is provided to you, then at that moment you can describe what is the name of the sketch, and you will be also able to describe the constructional details regarding that particular sketch of the mechanism. Third unit outcome is select suitable mechanism for the given applications with a justification. Suppose you want to develop any machine and the machine is having a certain application. At that moment you have to decide which mechanism should be applied. So after studying the whole subject theory of machine, you will be able to select suitable mechanism for the given application, and you will be also give the justification behind the selection of suitable mechanism. Next unit outcome is select suitable material of the mechanism for the given application with justification. Material is an important because every product is made with a suitable engineering material. So in this outcome is going to achieve. You will be able to select suitable material of the mechanism for the given application. Now in this particular lecture we will focus on point number 1.1, kinematics of machines, and the name of the unit number 1 is fundamentals and types of mechanism. In topic number 1.1 you will learn introduction to statics, kinematics, kinetics and dynamics. After that you can learn kinematic links, kinematic joints, pairs, chain and its types. Then types of constant motions, what is the meaning of inversion, and what is the difference between mechanism, machine and structure. So these are the points of contents of point number 1.1 of the unit number 1. Let us define what is theory of machine. The study of relative motion between the various parts of the machine and forces which act on them is covered under the field of theory of machines. Here I am mentioning study of relative motion between the various parts of the machine. A machine is made up of different parts, and between the parts there is a relative motion. This motion is created because the force is applied, and in this way what is covered in theory of machine, it covers relative motion between the various parts of the machine and the forces which act on them. The subject theory of machine may be defined as that branch of engineering science which deals with the study of relative motion between the various parts of the machine and the force which act on them, as I have already told the explanation of this definition. This knowledge of this subject is very essential for a design engineer or an engineer in designing various parts of the machine. Before designing any kind of part of the machine, the knowledge of theory of machine is essential to him. Let us see what are the subdivisions of theory of machines. The very first division is called as a kinematics. It is that branch of theory of machines which deals with the relative motion between the various parts of the machine. We have studied engineering mechanics at the very first year of our engineering. In that, we have studied how is the structure of force acting on the body. Engineering mechanics is divided into two parts. One is called statics and another one is called dynamics. Further, dynamics is also classified into two categories. One is called kinematics and second one is called kinetics. But in case of theory of machines, this kinematics is nothing but study of the relative motion between the various parts of the machine. What is dynamics? This is second subdivision of theory of machine. It is that branch of theory of machine which deals with the forces and their effects while acting upon the machine parts in motion. When there is a motion and when the motion is achieved, we have to study which are the forces acting at particular time and what will the effect. Mostly the effect of force is creation of motion, and that is this branch of theory of machine tells us, which is called as dynamics. Third is kinetics. How it is defined? It is that branch of theory of machines which deals with the inertia forces which arises from the combined effect of mass and motion of the machine part. So in kinetics, the mass is going to be considered and the inertia forces are considered, and this way this branch kinetics deals with the inertia forces which arises from the combined effect of mass and the motion of the machine parts. Next is statics. It is that branch of theory of machines which deals with the forces and their effects while the machining parts are at the rest. Statics means steady position, or there is no movement, equilibrium position, and that's why in this it is the study made related to the forces and their effects while the machine parts are at the rest, and the mass of the part is assumed to be negligible particularly. So this way these are nothing but four subdivisions of theory of machine. Number 1 is kinematics, number 2 is dynamics, number 3 is kinetics, and number 4 is statics. Before going through the details of kinematic chain, kinematic link, kinematic joint, we have to study what is the meaning of rigid body and resistant body. So let us try to understand what is rigid body. A rigid body is that body in which the distance between the 2 points on the body remains constant or it does not deform under the action of applied force. It is well known that when the force is applied on any kind of body, the elongation takes place and the motion also takes place. Regarding the elongation, the dimension changes in the direction of length, width and height. And when there is a force, particularly pull type force is applied, then there is elongation, and when the push type of force is applied, then there is a contraction of the body. All these dimensions are going to reduce. So in case of rigid body, it is said that the body does not deform under the action of applied force, means its dimensions are not going to change. What is second type of body under consideration? And this type of body is nothing but resistant body. Before that, I want to tell you that in actual practice, no body is perfectly rigid, but we assume it to be a rigid to simplify our analysis. In practical applications, all bodies are said to be resistant body, but we use the rigid body because it is said that that particular body is having very small deformation when the force is applied. So this way we can define rigid body. Now let us move towards understanding what is meant by resistant body. Resistant body. A resistant body is a body which is not a rigid body but acts like a rigid body while it's functioning in the machine. In actual practice, no body is rigid body, as there is always some kind of deformation while transmitting motion or force. So the body should be resistant one to transmit motion or a force. The example of resistant body, you can say that the cycle chain is the resistant body as it acts like a rigid body while transmitting the motion to the rear wheel of the cycle. So when we pedal the cycle, the motion is transmitted through the chain, and that's why the cycle chain is given here, the example of resistant body. Another examples are belt in belt and pulley arrangement. There is a belt and pulley arrangement, so belt is also called as a resistant body. After learning this, what is meaning of rigid and resistant body, we come to know, to understand what is the meaning of kinematic link. A mechanism is made of number of resistant body. Some may have motion related to each other. A resistant body or a group of resistant bodies with rigid connections preventing their relative movement, then it is known as a link or simply a kinematic link. So kinematic link is also a resistant body and it is having rigid connections. It is defined as a resistant body which has relative motion with some other element. The examples of kinematic link are crank, piston, cylinder and frame. This kinematic link is also known as kinematic link, simply link or an element. Kinematic element, kinematic link or simply a link, one and the same thing. It is a member or a combination of members of mechanism connecting other member and having motion relative to them. So link is playing a role. What is the function? To connect other members. Thus a link may consist of one or more resistant bodies. So in particular manner, a link is defined as a single part which has a resistant body or combination of resistant bodies having inflexible connections and having a relative motion with respect to other parts of a machine. A link is also known as a kinematic link or element. Link should not be confused with the parts of the mechanism. Different parts of the mechanism can be considered a single link if there is no relative motion between them. So this is nothing but the proper definition of the link. So again I am repeating, a link is an rigid body which possesses at least two nodes which are points for attachment to other links. Every link is having different nodes. How is the node? Let us understand. And with this classification, number one type of link is called as a binary link. Means what? The link is having two nodes. Number two, ternary link. This link is having three nodes. Number three, quaternary link. This link has four nodes, and the figure is given for binary link, ternary link, and quaternary link. In binary link, you will see clearly in this picture there are two nodes. In ternary links, you will see clearly in this picture there are three nodes, and in quaternary link you will see that there are four nodes. So kinematic link is also classified into three categories. One is called rigid link, in which there is no deformation or deformation is negligible. Flexible link, deformation is there but it is in the permissible limits. And fluid link, when motion or power is transmitted in the permissible limit with the help of fluid, then this classification is under consideration when there is a use of fluid as a link. So these are the three important types of kinematic link. So let us see by example how is the structure of kinematic link. In this figure you will see the single slide mechanism or single slider crank mechanism, which is having four links. You will see clearly in this picture the frame and the guides, crank, connecting rod and slider. So in this picture the link number one is frame, the link number two is crank, the link number three is connecting rod, and link number four is crosshead. However, the frame may consist of bearings for the crankshaft. The crank link may have a crankshaft and a flywheel also, forming one link having no relative motion of this. So by this picture we can understand how is the nature of kinematic link. Then let us understand what is kinematic joint. A kinematic joint is a connection between two or more links. So as there are number of joints in our body, human body, in the same way in case of machine there are number of joints. What is the function of these joints? These kinematic joints allows some motion or potential motion between the connected links. In this picture you will see the joints which are joining the four links, link number P, link number Q, link P, Q, S and I. Depending upon the number of links at the joint, a joint can be a binary, ternary or quaternary. Similarly, the link is also binary link, ternary link and quaternary link. The mechanism shown in this figure is also called as a crank rocker mechanism. And you will see in this picture there are four binary joints. A binary joint comprises two links and hence it is one kinematic pair. A ternary joint comprises three links and hence two kinematic pairs. So one ternary joint is equivalent to two binary joints. In case of quaternary joint comprises of four links and hence three kinematic pair. So a one quaternary joint is equivalent to three binary joints. So you should remember these points related to the kinematic joint. In this picture also we will understand what is binary, ternary and quaternary joint in depth. If two links are joined at the same connection, it is called binary joint. For example, in the following figure, with what it shows, a chain with a two binary joint named at B. So B connection is nothing but for a binary joint. If three links are joined at a connection, it is known as a ternary joint. It is considered equivalent to two binary joints, since fixing of any one link constitute two binary joints with each other, two links. So in this following figure you will see that point number T, joint number T is the example of ternary joint. And quaternary joint, if four links are joined at a connection, it is known as a quaternary joint. It is considered equivalent to three binary joints, since fixing of any one link constitute three binary joint. So this figure shows point number n, joint number n for quaternary joint, and this way we can understood here what is binary joint, ternary joint and quaternary joint. So joints are most important part of the mechanism. The resultant motion on operating a mechanism is determined by the kinematic joint connecting the members of the mechanism. The kinematic joint allows motion in some directions and constraint in the others. The types of motions allowed and constrained are related to the degrees of freedom. Degrees of the freedom means, in short, number of movements in different directions that we can achieve by developing a particular type of mechanism. Let us understand kinematic pair. After learning kinematic link or kinematic link and kinematic joint, now the third term is coming under consideration, that is called kinematic pair. Pair means we say many times that pair is good, that pair is bad. So try to understand what is the meaning of pair, and after that we can understand what is kinematic pair. When two links are connected in such a manner that relative motion between them takes place in a definite way, then it is called as a kinematic pair. So relative motion is taking place in a particular direction in definite way. So this is the meaning of kinematic pair. The two links are or elements of the machine when in contact with each other are said to be the pair. If the relative motion between them is completely or successfully constrained, then also the pair is also known as kinematic pair. Let us see the detailed classification of kinematic pair. They are classified as number 1. First option is according to the type of relative motion between the elements. According to the type of relative motion between the element, first classification is sliding pair, second is turning pair, third classification is rolling pair, screw pair and spherical pair. As the name suggests, sliding pair means the two elements have a sliding motion relative to each other. And the example is piston and cylinder pair. Second one is turning pair. When the two elements are connected such that the element revolves about the other element. So in case of turning pair, the element revolves, while in case of sliding pair, the elements slides. The example of turning pairs are shaft rotates in the bearing rotation of the crank in slider crank mechanism. Third classification is rolling pair. When one element is free to roll on another element, then it is called as a rolling pair. So rolling action is achieved. A rolling action can be seen in case of rolling pair. The examples are the belt and pulley surface constitute a rolling pair. Screw pair, as the name suggests, it is having a screw. In this type, the contacting surface is having threads. It is also called as a helical pair. One element turns about another element by means of thread only. The example is a bolt and nut arrangement, screw jack for lifting heavy weights. Let us see spherical pair. What is there? One element is in the form of sphere and turns about the fixed element, then it is called as a spherical pair. An example of spherical pair is ball and socket joint. So generally these pairs are classified by number 1 is type based on motion, type based on nature of contact and type based on mechanical constraint. According to the type based on motion, we are having this particular 4 important pair: turning pair, sliding pair, rolling pair and screw pair. Second, according to type based on nature of contact, higher pair and lower pair. And lastly, types based on mechanical constraint, closed pair and open pair. So we will learn all these types of pairs in further slides. So this is a sketch of sliding pair. You will see that there is a rectangular block which is inside the fixed block having the rectangular slot, and sliding motion is achieved. So sliding pair is constituted by two elements so connected that one is constrained to have a sliding motion related to the other. In this type, motion between the two kinematic link is in definite direction is sliding, hence it is known as a sliding pair. So as you can see in this sketch, the example sliding pair is that a block with a square or rectangular hole and a bar of rectangular or a square inserted into the block hole, then relative motion between the two link is sliding only. Another figure, you will see that turning pair. You will see that in this there is a crankshaft which is revolving inside the bearing. There is a rotary motion given to the crankshaft. Two collars are attached on both the sides to avoid the sliding motion. So only the turning action can be achieved. So kinematic links are connected in such a way that the relative motion between the link is definite and turning or revolving is known as a turning pair. That motion will be a turning or revolving. This is the sketch for rolling pair. As you will see, the best example, ball and bearings. When two kinematic links are connected in such a way that one link is rolling over other link is known as rolling pair. So ball bearing is a good example of rolling pair in which ball has a rolling contact with the shaft and outer surface of the bearing. This is a screw pair. As you can see, the threads, when one element turns about the other element by means of threads, they form a screw pair. The motion in this case is a combination of sliding and turning. So both the motions are achieved in case of screw or helical pair, which is called as a sliding and turning actions. Both actions are achieved. The example is lead screw of the lathe with a nut, a bolt with a nut, screw and nut of a screw jack are some examples of screw pairs. Now this is another option by which we can classify the pair according to the type of contact between the element, lower pair and higher pair. In case of lower pair, if a pair motion has a surface contact between the element, then it is known as a lower pair. So surface contact is achieved or there between as you can see in the lower pair, while in case of higher pair there is a line or point contact between the element. So cam and follower is the example of higher pair, while piston reciprocating in a cylinder is the example of lower pair. Another example of lower pair is shaft rotates inside the bearing. Third option of classifying the pair is according to the type of closure. Self-closed pair and unclosed pair or open pair. In case of self-closed pair, two elements are held together mechanically, while in case of unclosed or forced closed pair, the two elements are not held together mechanically, and the figures that you will see in the next slide. So this is the example that you are seeing in this picture. The closed pair means closed inside some structure, while in case the open pair, that is open. You will see all these points of differentiation, closed pair and open pair. So this is another picture which is known as a spherical pair. When one element in the form of sphere turns about the other element which is fixed, they may form a spherical pair. Example is the ball and socket joint, a pen stand, the mirror attachment to the vehicles are some examples of spherical pairs. Now let us turn towards understanding what is meant by constrained motion and what are their types. Constrained motion is defined as a mechanical pair which is having definite motion with respect to another element. So there is a definite motion. Mechanical pair, it is formed with the mechanical pair and it is having a definite motion with respect to another element. There are three types particularly of constrained motion. Number one is completely constrained motion. Number two is partially or successfully constrained motion, and incompletely constrained motion. Let us understand a completely constrained motion. Completely constrained motion is defined as the motion between the pair takes place in definite direction irrespective of the direction of force applied. So irrespective of the direction of the force applied, we can have the motion and that is taking place in a definite direction. Therefore it is known as a completely constrained motion. When motion between the two elements of the pair is in the desired or definite direction irrespective of the direction of the force applied, it is known as completely constrained motion. So sliding pair that you will see, it is having completely constrained motion. And in another picture on the right, you will see that a square bar in a square hole After that, a shaft with a collar at the end in the circular hole, and third one you will see the piston in the cylinder of a IC engine. So this is nothing but the picture of completely constrained motion. Second type is partially or successfully constrained motion. In this partially or successfully constrained motion, the motion between a pair is not completely constrained by itself, but it is constrained by some other means. Let us understand by seeing this example of footstep bearing. You will see that there is a shaft which is inside the bearing and the load is applied from the upward direction. The motion of the shaft in a footstep bearing becomes successfully constrained motion only when a compressive load is applied, and that's why it is called as a partially or successfully constrained motion. So when motion between two elements of a pair is possible in more than one direction but is made to have motion only in one direction by using some external means like a compressive force, then it is called successfully constrained motion. A piston in a cylinder of an internal combustion engine is made to have one only reciprocating motion due to constraint of the piston pin, which is external, cam and follower, and shaft in a footstep bearing. These are another examples of this type. Third is the incompletely constrained motion. The motion between a pair takes place in more than one direction, then we can say incompletely constrained motion. Example is circular shaft in a circular hole. As it may be either rotate or slide in a hole, both motions have no relationship with each other. Let us move towards understanding what is kinematic chain. When two or more kinematic pairs are joined together, they form a kinematic chain. So, two or more kinematic pairs, when they are joined together, they are called kinematic chain. There are three types of kinematic chain. Number 1, 4-bar chain. Number 2, single slider crank chain. And number 3, double slider crank chain. Let us understand the difference between kinematic pair and kinematic chain. Kinematic pair, in case of kinematic pair, two elements are connected together, while in case of kinematic chain, 4 or more than 4 elements connected together. In a kinematic pair have constant relative motion with respect to each other, while in case of kinematic chain, motion of any point on the link with respect to any other point follows a definite direction. So examples of kinematic pairs are cylinder and piston, crank and connecting rod, piston and connecting rod, crank and frame. While the examples of kinematic chains are 4-bar chain, slider crank chain and double crank chain. After learning this, let us see the important point, which is called as inversion. You will see that in this word inversion there is a word versions. So what is meant by inversion? Let us understand. We have already discussed that when one of the link is fixed in a kinematic chain, it is called mechanism. So mechanism, in case of mechanism, what is happening? One of the link is fixed. So we can obtain many mechanisms as a number of links in a kinematic chain by fixing. By fixing the link, we can add or we can get number of mechanisms. In turn, different links in a different chain. This method of obtaining different mechanism by fixing different links in a kinematic chain is known as inversion of the mechanism. When the different links of the kinematic chain are fixed, we get a different mechanism. These mechanisms are called inversions of the kinematic chain. So let us see what are the conditions of forming the inversion. A mechanism is a kinematic chain with one fixed link. So there should be the one fixed link to form the inversion. The fixed link is called as a frame. Different mechanism is obtained by fixing different link in case of kinematic chain. The process of choosing the different link in a kinematic chain for the frame is known as inversion. Thus, by fixing one by one link of the mechanism, we can obtain the inversion. So this is the most important condition of forming the inversion. We can fix one by one all the links and we will get the mechanism accordingly. The number of inversions of the kinematic chains are equal to the number of links in the chain. Let us see the meaning of mechanism. You will see the mechanism here, which is having a fixed link, connecting rod, follower or driven link, crank or driving link. So together it is forming a mechanism. When one of the link of the kinematic chain is fixed, the chain is known as a mechanism. So in case of mechanism, one of the link of the kinematic chain is fixed. It It may be used for transmitting or transforming motion. For example, engine indicators, typewriters, these are the examples of mechanisms. There are two types of mechanism. One is called simple mechanism and compound mechanism. In case of simple mechanism, what is happening? A mechanism with a 4 link is known as a simple mechanism, while the mechanism with more than 4 link, it is known as a compound mechanism. So what are the conditions for mechanism to be a machine? When a mechanism is required to transmit power or to do some particular type of work, it becomes a machine. In such case, the various links or elements have to be designed to withstand the forces safely. Let us understand what is machine. A machine is a device which receives energy in some available form and utilizes it to do some particular type of work. A machine may be regarded as an agent for transmitting or modifying the energy. And a machine is a combination of components which can transmit power in a controlled manner and which is capable of performing useful work. A machine consists of number of kinematically related links. So, machine is a combination of resistant body with successfully constant relative motions which is used for transmitting other forms of energy into mechanical energy or transmitting and modifying available energy to do some particular kind of work done. So let us see here, machine is having certain input and the output. The input may be mechanical, electrical, hydraulic or nuclear energy, and inside that machine you will see the current kinematic arrangement of link. Rigid links are there, rigid hydraulic and pneumatic links are there, and output will be the again mechanical, electrical, hydraulic and thermal energy. So a machine has a moving part which must be constant and controlled. So in case of input, you will see that there may be a force, velocity, energy, time and power. In case of output also, we will get force, velocity, energy, time and power. So every machine will be found to consist of system of parts which is called as a links or elements connected together in such a manner that if one be made to be moved, then all receive a motion, the relation of which to that of the first depends upon the nature of connection, or which is called as a connection means joint. The links may be rigid hydraulic, rigid pneumatic. The power input may be a mechanical, electrical, hydraulic, chemical or nuclear. And the power output may be a mechanical also, electrical also, hydraulic or thermal also. Examples of machine: heat engine. What is that? It receives heat energy and transfers it into mechanical energy. Another example of machine is electric motor, which changes electrical energy into mechanical energy. Third example is pump, for which the input is electric power and output is a hydraulic power. The majority of machines receives mechanical energy and modifies it so that the energy can be used for doing some specific task which is called as a work done for which it is designed. Examples of such machines being the hoist, lathe, screw and jack. These are the examples where you will receive all these receives mechanical energy. Another classification of machine is machines for generating mechanical energy. It converts other form of energy into mechanical work. For example, steam engine, steam turbine, IC engine, gas turbine, water turbines. Second category is machines for transmitting mechanical energy into other forms of energy or converting. Also, these are called as a converting machines. For example, electric generators, air or hydraulic pumps. Third category is machines for utilizing mechanical energy in the performance of useful work. Examples are lathe and other machine tools. So this is the difference between machine and mechanism. A mechanism is a single system to transmit the motion and its objective is to transmit motion only. While a machine is a combination of links having relative motion and has a capability of modifying available energy in a suitable form. Its objective is transmit mechanical energy. So what is the objective of mechanism? To transmit the motion, while the objective of machine is to transmit the mechanical energy. Mechanism transmit and modifies the motion while machine changes the mechanical work. So these are also some of the points of differentiation. So here you will see that machine relates to energy while mechanism relates to motion. Machine has many links while mechanism also has many limbs. But the examples of mechanisms are engine, indicator and typewriter, while the examples of machines are lathe and shaper. So let us see what is meant by structure. So a structure is an assembly of resistant bodies such that the body does not have any relative motion between them. So the body does not have any relative motion between them. A structure is meant for carrying loads only. For example, building, roof truss, railway bridge and machine frame. So in case of structure, no relative motion exists between its members, while in case of machine, relative motion exists between its parts. In case of machine, links are meant to transmit motion and force which are dynamic, while in case of structure, members are meant for carrying the loads or subjected to the forces having starting straining action. In case of machines, machine serves to modify and transmit the mechanical work, while structure serves to modify and transmit forces only. So shaper, lathe and screw, these are the examples of machine, while roof trusses, bridges, buildings and machine frames are the examples of the structure. So these are again the same differences that I have already told to you between the machine and structure. You can see the slide. Thank you very much.